Hello, this is Mrs. Taylor, and I am going to review what we have done with projectile motion and the calculator. So I am going to use the equation that we were using for our pumpkin chunking activity, and it was that the pumpkin had an initial velocity of 128 and was launched from a height of 68 feet. So if I need to answer these questions, when did it reach its maximum height? What was that height? When did it hit the ground? How long was it in the air? What was the initial height? And when did it reach a height of 100 feet? Those are all questions that I can use my calculator to answer. But in order to do that, I need to first enter the equation into y equals. So if I go to y equals, I type my equation, negative 16 x squared plus 128 x plus 68. And if I press graph, more than likely I won't see my entire parabola. I need to adjust my viewing window. Now if you look at the equation, the initial height was 68 and this initial speed 128 feet per second. So after 1 second I've already added 128 feet to that 68, so that's almost 200 feet. So my y-axis needs to reflect that. I need to be at least at 68 because that's where the pumpkin was launched, but I need to be even higher than that to see my entire path of my pumpkin. So if I go to window and I change my y maximum, just through trial and error, I'm going to try 200 and see if I can see the entire parabola. Almost there, but I can't see the very top. So I'm going to go back to the window and I'm going to just double that. I'm going to change it to 400, the y maximum. So if I press graph, I now can see the entire parabola. That's the entire path of my pumpkin. And I need all those points of interest, remember from the previous video, to know how to answer these questions. So from there, the first question was, when does the pumpkin reach its maximum height? Well, its maximum height is going to be the vertex, and I need to find that. So if I press trace and I move my cursor to approximately where that vertex is, and if I look at the bottom, I'm kind of seeing my coordinates as I go, and as I get really close, it looks like it's around x equals 4, and I can force my cursor to go exactly to x equals 4 by just typing 4 and pressing enter. It will go straight there, and I now have the vertex. The vertex is 4, 324. Now that I have that, I have the information I need to answer questions about a maximum height and when that height occurs. So the key is reading the question carefully. When dash your x value, because x represents time. What is the y value, because that's your height. So the way I could answer this question all in one sentence is I could say the pumpkin reaches a max height of 324 feet at 4 seconds. I've answered when it happens and what that height is. We're going to abbreviate this. Alright, so moving on to the next question. The next question says, when does the pumpkin hit the ground? Well, if I look at my graph, it is launched from 68 feet, hits this max height of 324, and then it will hit the ground over here at this x-intercept. So I'm going to use the trace function again to move my cursor over to where it crosses the x-axis. And if I look, it's at y equals 2 here at 8.48, and then if I move it, it's at negative 19. So I can't quite get my cursor to go exactly to the x-axis, but it looks like it's really close to 8.5. So I'm going to type in 8.5, and Lucky guess, that is my y-intercept, or excuse me, not my y-intercept, my x-intercept, because that's where y is 0. So I know my x-intercept for this graph is 8.5, which tells me the pumpkin is hitting the ground, height of 0, the ground, at 8.5 seconds. Now, if you think about the next question, how long is the pumpkin in the air? It's the exact same number, because the time it hits the ground is the time when it stops being in the air. So that would be 8.5 seconds. Exact same question. So copy, paste. There we go. Now, what is the pumpkin's initial height? Well, I kind of gave it to you in the setup, but if you recall what goes where in the formula, this 68, that's your initial height. The other way you can tell is by looking at your graph and going to the y-intercept. So if I move all the way over here, I can see my y-intercept is at 68. You could have also pressed 0 for your x-coordinate and taken your cursor straight there as well. Either way, my initial height was 68 feet. The last question, when does the pumpkin reach a height of 100 feet? Well, this is the problem where we needed a horizontal line to represent that height so we could see when this pumpkin's going to reach that height. So if I go back to y equals and leave my y1 as my equation but type 100 for y2 and press graph, I now have a horizontal line that represents the height of 100. And if this parabola is the path of my pumpkin, where that crosses that horizontal line, that's going to represent those points where that pumpkin is at a height of 100 feet. So the way I can figure out their intersection is I'm actually going to use the calculate menu of my calculator. So I'd go to second, trace, and I get the calculate menu. And I want to calculate an intersection, so that's number 5. So press 5. It's going to ask 3 questions. First curve, second curve, guess. First curve means make sure your cursor's on one of the curves. It is, so press enter. It should jump to the other line, and it did. That's my second curve, so I press enter. And then guess means move the cursor to the intersection. If you look, there are 2 intersections as the pumpkin's going up and coming down. I need to tell the calculator which intersection I want. So I press enter and it gives me that point of intersection at about 0.25. And we're using a graph. It's okay to estimate when you use a graph. So we're going to say the pumpkin reaches a height of 100 feet at approximately 0.25 seconds, and because there's a second point of intersection, I'm going to go through that one more time to calculate the other intersection. So second, trace, intersect, that is option 5, and I'm going to move my cursor over so I can see a little better which line it's on. It's on the parabola, so first curve, that's right, press enter. Should jump to the other line. It did, so I'm going to press enter. And now I'm going to move my cursor over to this second intersection. That's where it reaches that height going down. And I'm going to press enter, and it's going to give me an estimate, about 7.74. So at approximately 0.25 seconds and 7.74 seconds. So that would be my approximation for when the pumpkin reaches the height of 100 feet. So there's a really quick there's a really quick review of what we did with projectile motion in the calculator.